Alrighty, today we're going to create a strip layout for this part here, and we're going to use ProgSim to develop the cutting punches for it. I'll start by saving the part. And we will begin by taking the gusset out entirely. We are just going to use the ProgSim tool automatic blank development or the trim optimization to create the punches for us. All right, we can go back and name our station marks now. Save, and we'll run part preparation. And tell it that the bottom side is die side, and that we're going to use this line, the back edge, the center of which to be the origin. Just going to create some reference geometry, and we can run the create edit strip layout command. Needs a job number, and we need to name the strip itself. We run a single out, just going to run right to left. Puts in the two configurations that we add. So we're going to have a flat and then two more flats, and then our form and another one. So a total of 5 stations. And we'll save that. Now ready to range our part. I'll rotate it 90 degrees. Can adjust the spacing between parts. Give it 150 thousandths if we want, or we could just type in an actual value. And the same for the strip width it gets. When material thickness, we could put in a different value, or we can just type in directly. I'm also going to nudge this right off the edge just a little bit here, and I will hit apply. Now ready to start putting in our punches. I'll start with our punches for pilots. It's asking for points where we want the pilot, but we don't have it where we want it yet, so I'm going to add a sketch as a reference. I'm going to start by converting some reference geometry here. Then we're going to go center of that, and center of that, and I'm going to do a midpoint line out from there. That'll be coincident. This will be, oops. There we go. Now we've got a reference. We are going to put pilots here, and they are going to be 0.377 in diameter. Going to hit OK, and it will add those in for us. Going to add these interior cutting punches here. Going to add them in the 3rd station. Again, as we saw with the first one, it made an original punch and copied into the 2nd location. It's going to do the same for these, so that way it'll be mounted together later in our tool and also shows up as a quantity of 2 in the bill of materials. You can see that here with the colors, the dark original and the light copied. Going to move on to our next punch here. Throw a rectangle about what we want to do, and then we will make it coincident. And then we can use the search the punch outline sketch. It's going to find that whole area. I don't want this redundant sketch here though, so I'm going to drag this back and then back onto it. Next thing we want is a mismatch here. French stop, the cutting side and the reference side. Puts all that in for us automatically. We want our radius on this end and 100 thou on the back. And add some reference geometry here. That's one punch down. Get another one going here in a second. Just saying, draw a rectangle around the edge we want to capture, search the punch outline, and then we can modify. Drag that out, do our mismatch. Put 100 thou on the back since it's already 100, and we'll some more reference geometry. And one last cutoff punch here. Make this symmetric. I'll add a dimension. There we go. You can see on the red preview here that our mismatches are lining up. Oh. All right, we've got all our cutting done. We're going to go ahead and apply. Alrighty, we'll go ahead and save. Now we're going to start working on some more punches here. Show at the bottom side. We're going to pick the edge that we want first, and then we're going to pick everything else. And then we're going to draw a sketch. I want to use this edge as a reference, but I don't want to maintain that type of reference. So I'm going to make that link first, but then I'm going to come in and use my reference geometry here. And before that can move, I'm going to stick a distance on there. So that is now essentially the same as being collinear, but it won't update with it if it ever moves. So it just happens to be on edge right now. I'm going to keep this within the width of this here. There we go. Oops. All right, so this is going to make our punch here, but as you will see, has not cut the gusset at all. So I'm going to edit the punch, still in the context here. Since I selected the surface, they're all on there, so I'm going to use that surface body with the cut with surface command and cut that off. And now we have a gusset. Do more or less the same thing from the top side here. And we're going to pick one edge to be our bent radius as a 2D punch, and then we're going to pick all of them as our cutting surfaces. And then we're going to draw our outline again. Get our reference to center our sub. And one last construction. I want. So again, this is creating just a basic 2D white punch without any gusset on it, and then we are going to edit it and use the surface that is there. This time, the material is not there, so we need to add material. So what we are going to do is we're going to sketch on the top of the part, and we're going to draw a rectangle. I'm going to make this edge coincident. And just make sure it's wide enough for those gusset faces right here. I'm just kind of looking through and getting that in there. I could fix these or lock them down or something. We're going to extrude up to surface. So we're going to pick that surface. Oops, we're going to go that way. Oops, that way. And go up to surface. Come in and grab this surface here. Come on. Oh yeah, I can't do that in a strip context here. I always forget that. So I get out of this, how to isolate. And we take a sketch we created, we can extrude, we can do up to surface. There we go. And we can hide our surface again. There's our gusset. And we're going to use the form punch command one last time to make our last piece of geometry, our pressure pad right here. And we just need it somewhere in here to hold this down for us. All right, pressure pad. Done. Oh, I was going to change these. You can go back in to edit these just so you know. Just going to give it some color just so they're easier for the picking them up for the die simulation here. Okay, we are ready to simulate. Open the ProgSim tool. It's going to start loading in a lot of the data here. It does pretty well at guessing what we want, but we still need to go through and double check that it has done what we wanted. Start with the trim tool. It's picked up all our punches. Show up in the check element, and we're good with that. Go back, move on down the list. Next one's the upper form. It's picked up both of these parts. I created them both with the form punch command. They're above the strip, so it makes sense. But we do not want our pressure pad to be a form tool. We are going to grab the last few faces down on the bottom here. And you can check and look at what we got and see that it is indeed what we want. Keep on going down. Next is the counter lifter. Accept the name and then look normal to draw a big floating lifter across the top here. The only thing is that we need to just watch out for the gusset. So really the only thing is just don't touch this. Other than that, nothing wrong with having more because it's just going to support more material and keep it nice for the simulation. We're on both sides of the center line, so we are good. Next is the lower form. It's picked up the lower form and its faces. Confirm, and we like it. The lower lifter is the same as the upper lifter, so we just made that and we know it's good. Next is the OP boundary, accept the name, and then look at the drawing. And we're just trying to divide the part one from the next. What my goal here is to try and include some of the skeleton here. I need to go all the way out to the edge because this is going to define the shape of or the width of our material. But I'm going to come all the way into this center line here. And the goal, my only goal is here is I'm trying to put one lifter or one pilot in one and one in the other. I think I can actually just come all the way across with this. Go away. Or not. Close enough. There we go. So that's fully divided the part. And I can draw that in any station, and now it's patterned it all the way down. Pick our pilot holes. I'm going to hold Control. Pick the edges. It's going to pick up on the pattern of the edge up until it gets recognizes as a cutting punch. So I just do that for both of those, and it picks up the second one. And the last thing we need here is our pressure pad. I tell it this block did not pick up the face. I'm going to pick through the hole here. So I'll tell it there's 2 inches of stroke, initial force of 2,000 pounds, and hit confirm. We've got our basic strip stuff set up here. Go down to the bottom, get the rest of our stroke. The lifter is going to move the same as the pad, 2 inches, and we're going to make the lower lifter 2 inches as well, just for the sake of convenience. The overall stroke is going to be 8 inches. No, we can make it even shorter. We can make it 6. Thickness of the part is indeed 50 thousandths, and the progression of the part is indeed 3.5. Got our cold roll material selected, and we're going to use the medium default friction. We can, from here, go ahead and hit compute to make sure that our simulation makes sense. And then once we know that it's working, we're going to set it up to optimize the cutting punches. See all that material drawn in. That's what we're going to ask the cut optimizer to make up for. All right, so simulation worked. So we're going to come over to the computation tab, and we are now going to ask it to run the cut optimizer. Use this 5th tab here. We're going to ask it to go within 10,000. It probably even goes closer. Let's ask for 7,000. But we're not going to ask for it to optimize the whole part. We're just going to optimize the tab because the rest of it's being carried and it's being cut and it's not really being developed. So it's only this tab part that matters. So it's identified the outline. I'm going to create a sketch. I'm going to come in here and grab all this extra stuff. Delete that. And then we're also going to drag this back from the edge a little bit, which helps the simulation.
So now we've got the edge of the part defined here, and we're going to tell it, please get within 7 thousandths of that. So we're going to go ahead and launch the computation again. Just run through basically the same simulation over again. It's going to compare to that line we gave it now. See, it's come in here with that oversized material now. It's getting a lot closer just on the second attempt. Alrighty, so we can see the cutting punch that it has suggested, and given the green line here, we're now fully within 7,000. Let me click on it. Maybe not. Anyhow, so we can take a look at the formability if we like. It's indeed a formable part. Spring back here, got 6 thousandths worth of spring back. So now the next step is we've got this cutting geometry in our simulation. We need to make that back into our form punch here. That is basically just a polyline mesh line that was made for that, and it is not nice geometry that you want to cut. So we're going to go into this punch here, and Logopress has a tool called Optimize the Cutting Punch Outline. And it's going to bring in that polyline that was used to cut the part in the simulation. And it is just a line right here. This is not a line. It's not even really a spline. It's just a... So, but what it's saying is we're use this whole thing. Do you want to keep it all, or do you want to retain part of my old geometry? So I'm going to click here and tell it to delete all of this. We're going to erase that portion, and it leaves the front portion all in the magenta color of the line. The next thing we can do here is go to the outline merge arcs command. It's going to try to divide this down into lines and arcs. Each of these is it's an arc with maybe space between it or not. That's tangent to the next arc. The flat, an arc, a flat, an arc, and each of the triangles is kind of the radius of the arc that it's on. So we can kind of look at these and try to decide if we like what it's come up with. We're going to try to merge some of this, try to make a little less choppy outline. Most of what it's come up with is pretty good. I'm not going to try to merge too much of this here. But at the end of the day, you can still just come in with SolidWorks sketch entities and change what you like. But most of this is pretty good. So I'm just going to go ahead and hit OK. And it's going to make this into actual sketch elements now. All right, and the last thing we need to do is connect this back up. So I'm going to window that, get rid of that, and I'm going to get rid of that, and I'm going to put our 10 thousandths fillet back on the edge here. And we're going to come over here, and I'm going to wipe out all of this for similar purposes. Oh, can't be in the fillet command. Wipe out all of that because we don't want that anymore. And we'll wipe out that. And we can do the same with the punch mismatch command. Maybe not. Let's try that again. There we go. Just got our mismatch back on there. So we can go attempt to simulate that punch again or not if we like. The only other thing we might want to do here is I'm going to hide this punch. We're going to get rid of these extra bodies here. We're going to edit the skeleton. And we are going to find these two bodies that we want to get rid of. This one and this one. And maybe that one too. I'm going to delete that one too. And we're going to use the delete bodies command and delete it. And that's now at the bottom. And then we're going to use the Logopress one, unsuppress on the following stations. And it's now gone on the rest of them. There we go. Nice, pretty strip. And we'll save that. And we're done.